Starting with the methodology for the climate classification for the Africa, the first comprehensive climatic classification system, as shown in the figure, was developed by Waldemar Köppen in 1884. It is based on the concept that native vegetation is the best expression for climate. Climate zone boundaries were selected with vegetation distribution in mind. Existing classifications of the climatic zone of African countries are based on the same concept. Buildings, to be low energy and sustainable, must be climate responsive. Both buildings and vegetation are best suited to the environment according to climatic parameters such as temperature, humidity, solar radiation, and wind. But they react differently to the same climatic input. For this reason, the last modified Köppen's classification, Köppen-Geiser system, has been verified methodologically for its adoption to the building energy design. It has been observed that in such a large scale, like African continent, this classification with minor modifications could be adopted fairly for climate-responsive building design. To accomplish this task, a methodological approach based on the processing and analysis of climatic data in relation to their impact on building design strategies was used. Mahoney's table and Givony bioclimatic chart were used, and in addition, data were analyzed in detail according to their average hourly trend, and thereby design strategies were derived. The combination of these three methods led to the adoption of Köppen-Geiser classification with minor modification for deriving the building design studies in different climatic zones. The main classes of climates identified for the African continents can be grouped into three different categories, each indicated with a capital letter from A to C. A. Hot, humid climates. B. Arid climates. And C. Temperate climates. Of these three, the dominant climate type by land area is the arid B, 57.2%, followed by hot, humid A, 31%, and temperate C, 11.8%. In this lecture, the details about the characteristics of Group A, which is hot, humid climate zones, will be discussed. Hot, humid climates are found in a belt near the equator extending to about 15 degrees north and south. The temperature of the coldest months exceeds 18 degrees Celsius, characterized mainly by the high temperature due to the lack of a real cold season, and the annual temperature swing is always comprised within very modest limits. The daytime variation is slightly higher, and this clearly differentiates hot climates from temperate and cold ones. On the other hand, both the quantity and the precipitation regime vary considerably in different places, producing different types of hot, humid climates, precisely classified and differentiated on the basis of the variation in precipitation patterns. The areas nearby Great Lakes, the temperature is slightly lower, but daily variations are comparable. Within Group A, there are two types of climates, AF, equatorial climate, and AW, tropical climate. Equatorial climate is characterized by a great uniformity of the thermal regime and by abundant rainfall, well distributed over all the months of the year. Representative location is Mombasa in Kenya. The temperature is high and almost uniform throughout the year. This is justified by the considerable sun height above the horizon and small variations of the day length that occur from one month to another. Average monthly temperatures vary between 25 to 26 degrees Celsius. The annual temperature range is very small, 2 to 3 degrees Celsius, and the daily one around 10 to 12 degrees Celsius. The diurnal temperature variation remains modest due to the high value of relative humidity from 55 to 100% and cloud cover from 60 to 90%. The latter also results in the modest sunshine duration, which never reaches half of the theoretically possible hours, and which indeed has lower minimums in certain coastal areas. AW tropical climate. Representative location is Kinshasa in Democratic Republic of Congo. Differs from the equatorial one, both for the small quantity of annual precipitation and the existence of the two clear distinct seasons, a wet and an almost dry one. The average temperatures are similar to those of AF, but the temperature swing is higher while the relative humidity is lower. In the dry season, which is also the cold one, there are long periods of clear sky interrupted by thunderstorms or days without overcast sky. The transition to the AW climate is revealed through the plant landscape by the replacement of rainforest, typical of the areas closest to the equator with the savanna. Combination of high temperature and high humidity causes discomfort. It can be seen from the figures. Ventilation that facilitates convective and evaporative cooling of the body is essential for comfort both in day and night. High thermal mass is not helpful. Nights, which are often still and sultry, bring little or no relief to the heat of the day. Even lightweight, correctly designed houses will emit heat, very often causing indoor temperatures higher than outdoors. Therefore, minimizing of discomfort at night is of utmost importance. The locations nearby Great Lakes have a remarkably stable climate with very slight seasonal and daily differences of temperature and humidity. In order to design properly sustainable buildings in Africa, designer must take into account the characteristics of analyzed climatic zones. The characteristics of the group B, arid, and C, temperate climates will be discussed in the next lectures.